Good morning, grade 11 students. I am your teacher on air, Teacher Kim. And I will always be with you every step of the way. Together, we will explore statistics and probability. Hop on, enjoy, and learn. Are you excited to learn more today? Grab your paper, pen, and self-learning module, and let's start our lesson. Let us identify first the appropriate rejection region for a given level of significance when the central limit theorem is to be used. But before we proceed with it, I want to discuss first the main purpose of statistics. The main purpose of statistics is to test the theories or results from experiments. For example, you might have invented a new fertilizer that you think make plants grow 50% faster. In order to prove your theory is true, your experiment must repeatable compared to a known fact about plants. Take note that in this example, probably the average growth rate of plants without the fertilizer. We call this type of statistical testing a hypothesis test. Specifically, it is an area of probability that tells you if your theory, your hypothesis, is probably true. In my example, I will briefly go what is a rejection region is. In this example, I will assume you don't have to calculate the alpha level and confidence level. Let's say you have a 95% confidence level and it will give you a 5% alpha level. Let's start with the one-tailed test. This area is a tail, and it is our 5% alpha level, and the remainder of the distribution is a 95%. We can say that our alpha level is 0.05. What it means is, this area is the probability you're gonna incorrectly reject the null hypothesis and you're gonna run the hypothesis test. This point right here, this is a normal distribution, you're gonna find the z-value. And the z-value corresponding to a tail of 5% is 1.96. When you run your hypothesis test, you're gonna get a z-value. And when your z-value falls into the rejection region, this alpha level, let's say you have a z-value of 2.0 and 2.0 is larger than 1.96 and it's gonna fall into each region, we could reject the null hypothesis. Let us say we have two tails. Again, we have a 95% confidence level. And we have 5% alpha level and it will be divided into two tails and it will give us 2.5%. And let's get the value, the z-value here at both tails. This level is your rejection level. When you run your test and it falls into the rejection region, your null hypothesis is reject. Another that is connected to rejection region is the p-value. Some statistical tests will use a p-value. For example, we have a p-value of 0.02. A p-value is also a kind of rejection region. Again, let's say you have a 95% confidence level and a 5% alpha level, and split it to 2. And the rule is, if your p-value is smaller than your alpha level, then you will reject the null hypothesis. The problem that most people have is they look at this value of 0.02 and it doesn't make any sense. But if I change this into percentage, which would be 2%, the p-value of 2% is saying that there is a small area in this tail here that is 2%. If the area of the p-value is smaller than the area of your alpha level, you can reject the null hypothesis. Every rejection region can be drawn on a probability distribution. The image shows a t-distribution with a two-tailed rejection region. It is also possible to have a rejection region in a one tail only. Let's see through an example the difference between two-tailed and one-tailed rejection region. Which type of test is determined by your null hypothesis statement? For example, if your statement asks, is the average growth rate greater than 10 cm a day? That is a one-tailed test because you are only interested in one direction because of the word greater than 10 cm a day. You could also have a single rejection region for a word less than. For example, is the growth rate less than 10 cm a day? A two-tailed test with two rejection regions would be used when you want to know if there's a difference in both directions, greater than and less than. Let us know rejection regions and alpha levels. You, as a researcher, choose the alpha level you are willing to accept. For example, if you wanted to be 95% confident that your results are significant, you would choose a 5% alpha level. That 5% is the rejection region. For a one-tailed test, the 5% would be in one tail. For a two-tailed test, the rejection region would be in two tails. Let's know the rejection region and the p-values. There are two ways you can test your hypothesis, with a p-value and a critical value. P-value method. When you run your hypothesis test, the result of the test will be a p-value, and the p-value is a probability value. It's what tells you your hypothesis statement is probably true or not. If the value falls in the rejection region, it means you have a statistically significant result. You can reject the null hypothesis. If the p-value falls outside the rejection region, it means your results aren't enough to throw out the null hypothesis. What is statistically significant? In the example of the plant fertilizer, a statistically significant result would be the one that shows the fertilizer does indeed make plants grow faster compared to the other fertilizers. Rejection region method with a critical value, the steps are exactly the same. However, instead of calculating the p-value, you can calculate the critical value. If the value falls in the rejection region, you can reject the null hypothesis. Now, let us compute and draw a conclusion about the population proportion based on the test statistics value and the rejection region. In this example, we assume we are testing some claim about population proportion. As usual, the following conditions must be true. That is, number of samples multiplied to the population proportion multiplied to the quantity of 1 minus the population proportion is greater than or equal to 10. And 2. Number of samples is less than or equal to 0.05 multiplied to the total number of the population. And we have steps to follow. Step 1. State the null hypothesis and alternative hypothesis. State very clearly what are the null hypothesis and the alternative hypothesis. Here's a table that will guide you how to state your hypothesis in symbols. Step 2. Decide on your level of significance. That is your probability of your type 1 error. So basically, that is your threshold for how you are comfortable of being okay or wrong, saying the alternative hypothesis is true and really you just observed something unusual. The level of significance kinda depends on the consequences. Step 3. Compute the test statistics. Step 4. Determine the p-value. Step 5. Reject the null hypothesis if the p-value is less than the level of significance. Step 6. State the conclusion. When you state a conclusion, you should also include a measure of strength of the results based on the p-value. For the population proportion, the test statistics is shown in the formula. For example, traditionally, the success rate of students in Math 101 who enrolled is about 55%. considering only incoming students in last 2017, 2018, and 2020, there were 88 students in Math 101 who earned a high school GWA of 3.5 or better, of which 78 were successful. Is this enough evidence at the 5% level of significance support the claim that these students are more likely to succeed in Math 101? We get a 55% are usually successful and we are wondering more likely to succeed. So we have our null hypothesis and that is our proportion, that is 55%, and our alternative hypothesis is more than 55%. And we have here our level of significance that is 5% and that is alpha is equal to 0.05. And we look into our data, we have 88 students and 78 were successful. So we have a sample proportion x over n and that is 78 over 88. For our null hypothesis, we have a proportion is equal to 0.55. And for our alternative hypothesis, we have a proportion that is greater than 0.55. Step 2. Decide on level of significance. That is, alpha is equal to 0.05. Step 3. Compute the test statistics. For this example, we will use the Z formula. That is, sample proportion minus mean, all over square root of mean multiplied to the quantity of 1 minus mean, all over number of sample. Step 4. Determine the p-value. Out of our test statistics, we will get a very small p-value that is 0.0001. Since the p-value represents the probability of observing our results, or more extreme, the smaller the p-value, the more unusual our observation was. We can use the following guideline. First, p-value is less than 0.01, means very strong evidence supporting the alternative hypothesis. Second, 0.01 is less than or equal to p-value is less than 0.05, means strong evidence supporting the alternative hypothesis. Next, 0.05 is less than or equal to p-value is less than 0.01, means some evidence supporting the alternative hypothesis. Last, p-value is greater than or equal to 0.01, means weak to no evidence supporting the alternative hypothesis. Step 5. Reject the null hypothesis if the p-value is less than the level of significance alpha. Since the p-value is greater than your alpha, reject the null hypothesis. We definitely have enough evidence to support our alternative hypothesis. Step 6. State the conclusion. So there is enough evidence, very strong evidence to support the claim that the proportion of students who earned a 3.5 or higher cumulative GPA are successful in Math 101 is higher than 0.55. For your assignment, number 1, state the null hypothesis and the alternative hypothesis. Number 2, determine the level of significance. Number 3, compute the test statistics. Number 4, determine the p-value. And number 5, state the conclusion. For the problem, approximately 56% of ISU Kawayan students are female. Suppose we wonder if the same proportion is true for the math courses. If we collect a sample of 200 ISU Kawayan students enrolled in math courses and found that 100 of them are female, do we have enough evidence at the 10% level of significance to say that the proportion of math students who are female is different from the general population? Take note, be sure to check that the conditions for performing the hypothesis test are met. That's all for today. Again, this is Kim Francis Season Alum saying, set your goals high, always dream big, because you are as big as the dreams you dare to live. Bye!